So, well, here with us is Eva, that is going to moderate the session. Yeah, Eva.
So we're moving on to the presentation of the use cases. And we have here live or the use case manager, which is a fantastic feeling. And I feel a little bit like, you know, girl power needs to
Energy.
be
Flowing.
And we're going to go according to scale, starting from local, going up to global. And we start with the GNIBIC microgrid operation. That case aims to investigate the scenario of a possible blackout in more detail. And the scenario takes place in the town called GNIBIC in Austria. And we have here Thomas Knapp, who's going to explain us more about it.
Nice. Hi, everybody. Pleased to meet you all. So I'm going to tell you something about the GNIBIC use case, which is our smallest use case in the WIPE project. We can go to the next slide. So GNIBIC is, the region of GNIBIC is 2,300 inhabitants strong. So metropolitan area, as you can imagine. It's a very small village and with a quite small area, and it's part of the municipality of Feldbach, which is in the southeastern part of Styria, in the south of Austria. Next slide, please. The GNIBIC use case focuses on the issue of blackout. As you've probably heard me say a couple of times already, the mayor of the municipality of Feldbach is quite keen on the topic of blackout. So there have been quite some actions there already to get people ready in case of a blackout and prepare for a 2 week of self-supply. And the GNIBIC electricity company, which is a family-run business for a couple of generations, has a small distribution grid, about, I think it's 2,000 to 3,000 connection points, so not too big, really just a very small company. They have installed a blackout backup system in their grid to supply a very small proportion of their grid with electricity in case of a blackout. So they are connected to the upper level distribution grid at one coupling point. They can themselves decouple there, and they can decouple parts of the grid. As you can see in this slide, the small red area is the core grid part of the GNIBIC grid, and they can decouple all the other transformers manually, and then supply approximately 10 buildings, which are critical infrastructure. So the firefighters, the kindergarten, their own base of operation, and some municipality buildings with blackout electricity coming from a local generation hydro and PV. They have a small hydro generation plant, which is sadly producing less and less energy each year because water is drastically going back. You can see that from one year to the next. That's really worrying. And also PV, and but they also, for blackout mitigation, they use diesel generators as backup because they need fast control to change the situation. Yes, and that's part of the local energy supply company and grid operator. That company is not unbundled because it's too small, and that makes some things easier. Next slide. The key objective here for the research is whether or not the blackout effects can be compensated, and whether or not the blackout plan is feasible. And why comes in at this point, because the backup power for this blackout case is quite substantial, by far bigger than the actual loads. They have 250 kilowatt of power generators, and they supply like 6 to 7 buildings. So there's a bit much power for that for that little load. So we're analyzing whether or not additional households could be supplied. So there are some areas where a couple of people live in a multi-storage building that could easily be connected or disconnected, and that's something. And we want to analyze whether or not we can do that. And another part is for the energy supplier, the acceptance of new energy services. This, I have to say, is all very theoretical at the moment, because the energy supplier in Gniewing is struggling heavily with the current situation. They have dropped off 1/4 of their customers in the last couple of weeks. Those are customers that have been supplied for 20, 30 years, which they had to cancel, because otherwise they would run bankrupt. And so at the moment they have other issues at hand than a research project, but nevertheless, the topic still is ongoing. Next slide. So what are we going to analyze here? So basically we want to see what policy interventions will take place in form of information and communication instruments when it comes to new products that the energy supplier will supply. And then the more important part from my perspective is not the policy intervention, but the technical intervention on household level. How would people react if suddenly there was no electricity? So there is a blackout case, but they would be provided with backup energy. Would they change the behavior? For instance, no TV, no dishwasher, or something like that, that they really go back to basic or not? And if we know that and can have that simulated, we can say, okay, well, we will expand the blackout supply in that region. Next slide. What are we expecting? What does the grid operator want there? Basically, they need the information if they go on a transformer station and leave that transformer station on the grid. In the case of a blackout, how would the aggregated load profile be? They're not so much interested in the individual household, because they won't supply individual households. They have to do that on transformer level. And also what effects that would have on the generation, what effects that would have on the grid, because a grid run with very low capacity can also be an issue. And then grid strain and how much diesel it would consume, because that's another factor. Having the power to supply more people is nice, but you also need to think in the long run, if the case of a blackout persists for a longer duration and you run out of diesel, that's not good. And finally, also the smaller part, which is not that important at the moment anymore, is how people would react to new energy services, because at the moment, nobody really cares about new energy services in times of very high prices. Okay, that's it. Thank you.
Thank you, Thomas.
We continue with the energy communities use case presented by Cruz Borges. The Y energy communities use case aims to create tools to support emerging energy communities in Europe and help them establish themselves as sustainable entities. And it aims to provide data demonstrating the benefits of these communities, with the Y Toolkit providing powerful tools when it comes to establishing a new energy community, hopefully.
Thank you.
So let's hear about it, Chris.
Okay, so, well, this is also a joint action with Coyener. So only one person could be here. I will take the position. Let's see. So again, we are here. We are going to assess, we are going to explain a little bit about the energy community and what we have been doing. And I mean, the key objective is to create tools to try to size and to define energy communities. Let's say it's a planning tool. And at the moment, there is a lot of problems. The principal one is lack of regulation. Let's say there is two directives that explain what an energy community should be, but then they have to transposed to the national regulations, and it has been quite fun transposition because each country is doing whatever they want, and there is some differences. Some countries have put some comments and others no, and some have transport all the thing and others no. So now at the moment there is a problem that nobody knows what an energy community is, and if you ask people what an energy community is, not two persons agree with the definition. So this is one of the first things. But the second one is that when you have some institution that know what are an energy community for them, they starting to making you the hard question. That is, for example, a spatial assessment, what and where could be deployed according to the national law, because this changes between different countries. And then the technical assessment, and then trying to make simulations of the people, what is going to have there, because in some cases you have data from smart meters, but there is the GDPR regulation that don't allow you to take this information. And in some other cases, it could be similar to what Thomas was explaining before, that you have a transformer and you can take the load from the transformer and that's it. But in some other cases, this is not so easy. Then we have another question, like if you can make internal flexibility, peer-to-peer market, external flexibilities to flexibility markets, if the net balance, I mean, if you can think on the energy community as a microgrid or not, and I mean, and these all things are there. And then there is a lot of economic assessment on what the first one and the most important one is, okay, how you are going to build inside an energy community and how you are going to split the cost and the incentive, I mean, and the revenues inside the energy community. Then we have, I mean, the impact assessment. Now, I mean, the impact in the sense of environmental, and also, I mean, one of the last points is the social assessment. I mean, how the energy community will contribute to fight poverty, inequality, what are the right governance structure social for the community, and what are the right incentives for people to want to be part of the energy community. So this is the key problem at the moment. The objective of the energy community is to try to answer who should involve, how to involve them, how to size the components, and what are the business and legal entities that are most effective for the energy community, how to manage the movement that happens naturally in the energy community, and how to build the energy community, and how are the control strategy if you have a control system there to be deployed. So we are working on two scenarios. One is a bottom-up energy community. It's a residential block of around 27 houses. This is something that the residential, I mean, the people that are there wanted to foster. So it's a grassroots movement, bottom up. And then we have the top down, the other one. This is a public authority or a utility that decides that they wanted to become an energy community and provide new services to their customers. We are assessing both of them. Both are completely different and have completely different problems and demand completely different solutions. So what has been done so far? For the bottom up, we have already 2 meetings with the citizens. We have used a preliminary version of the way Toolkit to create some simulations or proto Toolkit, let's say, or other tools that are going to do things similar to what we wanted to do with the Toolkit to make some simulations. And we have agreed with the locals, with the residents, an investment plan. The investment plan goes in that direction. I mean, the creation of the collective self-consumption. Then we wanted to improve. They wanted to improve the existing heat pumps, and then they wanted to build an energy community to start putting all the assets there. Because at first there is 1 building, but as you see, the complex has 5 buildings, sorry, and there is a 6th plant. And it could happen that all of them be part of the energy community and share and will easy the management of all those things. They also wanted to go for an electric vehicle point and an energy management system. So I mean, they have a long-term plan, let's say, and now they are starting moving, let's say. From the top down, we have already making contacts with the government board. We have already presented the use case. We have also making the same assessment with the same tools. We are going to start retrieving more information about the users that are there that could be part of the energy community. And we wanted to pass the surveys to know more about the behaviors, and we are leveraged on the information that we know. I mean, the surveys that we have done so far. And yeah, we are going to be in a close collaboration with them in order to try to explain to them what are the results that we have done so far into the project. And next steps for the bottom up, what we are starting doing now is to contact the suppliers in order to start executing the plan. And the key point here is that in order to get to the third line, we need to have guidelines for governance structure and business model, because so far what we have seen is that the governance structure are sometimes fixed, let's say, and sometimes, depending on your community, they don't align quite well. I mean, because they are fault for example, the most traditional one that is the top down, or for huge communities where this governance structure could make sense, and the business model could also make sense. For other communities that are smaller, perhaps it's not the best idea, and we need to think twice. We are trying to assess all those aspects and trying to make some guidelines. And then for the top down, what we wanted to do is to test the simulation, test the tools, making some more simulation, trying to assess a little bit more, or know a little bit more about this energy community and what are the technical solutions that will work best. Also, we wanted to make some surveys to improve the feasibility of the things that we are going to deploy there. And I think that's it.
Thank you, Cruz. And now we move up to the European level and the European energy strategy. The why European energy use case will create a model to examine different measures the EU has put forth to reach the decarbonization goal set in the Fit for 55 package, very actual, being voted on currently, and it will focus on energy efficiency measures and decarbonization efforts, as well as their impact on different stakeholders. Thank you, Otis.
Thanks a lot, Hiva, for the introduction. Yes, actually, the European use case is, let's say, relatively bigger one. It's on a larger scale relatively to the ones that have been introduced before. In this use case, our objective is to assess the impact of different interventions related to energy efficiency and what will be their impacts on the European economy, society, also related to the decarbonization ambitions of the EU, and then overall socioeconomic assessment. So for this, we're gonna rely a bit on the PRIMES model, which is, let's say, the model that has been used so far for all the Fit for 55 assessments, but we plan to actually expand a lot of this model in order to integrate also the white toolkit in all this. So next slide, Cruz, thanks. So as I've said, the objective is to actually make a soft linkage between the white toolkits and the PRIMES buildings model in order to quantify the systemic implications of different interventions, but capturing both the demand side, I mean, the building side, the residential sector, but also the supply side of the system. So in order to have a more holistic representation of the reality. Of course, the issue of changes in energy prices is a huge one, but also issues like sectoral substitution, like fuel mix, etc., will be considered in this case study. And our, let's say, the final step is actually to reevaluate the climate neutrality pathways that have been set out by the European Commission and re-examine them based on the improved modeling capacities developed in Y, in order to assess their feasibility and also implementation barriers and challenges when we actually move beyond the annual resolution that the models have, and we consider higher temporal and spatial granularity, which is now offered by the Y toolkit. And we want to test that through this use case. Next slide, please. Thanks. So we have made several steps until now, several activities in order to go towards this objective. The first actually was the design and implementation of the European use case workshop, which I think was last May, where our colleagues from RGI helped actually a lot in all this, where we have gathered around 15 or 20 high-level European stakeholders in order to discuss the issue of energy efficiency, of policy instruments to drive the transition. The core theme was, of course, the decarbonization of the European building sector, but we also had a lot of other issues, like, for instance, electrification, like social issues, for instance, energy poverty, which is now prominent, the Fit for 55 package, the post-COVID recovery packages, etc. And in this session, the aim was to actually analyze, classify, and prioritize a bit the policy instruments in order to drive the transition. So the focus was on the policy side of things and what policies or combination of policies can actually help us drive the transition to neutrality. Next. Thanks. So just a very brief reporting of all these use case that has happened. Here we just see, let's say, a table with all, let's say, the stakeholders' opinions on various issues. And we try, let's say, to categorize a bit the policy interventions along the different dimensions that are relevant for energy efficiency. And then we also try to prioritize a bit according to two axes: the effectiveness, I mean, the mitigation potential, the CO2 emission reduction potential to be, let's say, more correct, and the implementation barriers that each of these policy measures faces. For instance, we see carbon pricing, which was mentioned before, which means, of course, increase in energy prices, is a measure that, of course, was, let's say, characterized as highly efficient because it indeed can drive the transition, but on the other hand, has very high implementation barriers because, of course, people do not want to increase their energy prices, and this is quite logical. So, and we try to prioritize a bit in order to classify them and identify the policy instruments that actually will be then used to be modeled in prime. So we plan to introduce all these policy instruments in primes, or a list of the subset of them in primes, in order to actually analyze their impacts on energy consumption. So next, please. Thanks. This is, I mean, the modeling tool that we're going to use, which is the primes buildings model, and of course, let's say, is a model that's very heavily focused on the demand side of especially the residential and the services sector, but it also has links, let's say, to the electricity sector, which is also quite important here. And it's just a brief sketch of the modeling tool that we're going to use. I mean, it's not another place to be more in detail, but I mean, essentially, what this model can capture, let's say, all the different ways to reduce energy consumption, starting, let's say, from conducting deep renovation strategies to the level of changing the space heating or the cooling equipment that you have, down to the level of appliances and how you can use different, more efficient appliances or change, of course, the schedule of their operation. So next, please. Thanks. And some preliminary, let's say, input or output actually of this model. I mean, just gives you a brief sketch of what can be expected from that. It shows the fuel mix, for instance, in the residential sector in a baseline scenario. But of course, this is not just, let's say, a baseline. But then when we implement the policies, we can assess, let's say, the differences in fuel mix due to changes in policy instruments. Next. Thanks. So, of course, we have identified some KPIs to measure. These are a whole list of them, but probably some quite important, let's say, indicators to always have in mind when we assess the scenarios are emissions reductions, energy efficiency improvements, the share of renewable energy or the share of electrification in buildings, but also the impacts of decarbonization on energy system cost and electricity prices. And also now they become a lot more important, the issues of energy affordability and energy expenditures, but also the energy poverty, especially for those that, let's say, are living on low income. So all these will be quantified by the European use case. Next, we have already done some preliminary publications, which I will not, let's say, go into details, and now the next steps, which are most important. So let's say the most important next step is actually to find the most suitable way to integrate the white toolkit with the primes buildings model, which will be done using this Y plugins. And of course, then we will test this modeling improvement. So we have the before and after versions of the model. We're going to define these new scenarios to assess the different decarbonization strategies. And here's the most important actually aspect is that, of course, in addition to the Fit for 55 package, of course, we have planned to include, let's say, the new policy landscape, which is rapidly evolving. Issues like the REPowerEU, what we discussed before about the change in energy prices, potential ban on Russian imports, and all that. So we plan to really take this into account in the analysis. Next. Yeah, and of course perform new scenarios for all that and assess the policies feeding into the Work Package 5 deliverables, and assess all these policies relative to the KPIs that we have already defined before. And I think that's it. Yes.
Thank you, Panagiotis. And we move on with to the global landscape, because we're not existing in a vacuum here on this planet Earth. The Y global energy scenario use case wants to further improve integrated assessment models by enhancing the knowledge about consumer behavior and their decision-making process. And it will create a link to other energy models already in use and implement the results of the Y toolkit there. So Francesco, tell us more.
Yeah, thanks, Eva. So, well, let me start by saying that I'm going to be brief because I'm standing between you and lunch. Maybe a small discussion in between, I don't know.
Yes.
Yeah, okay. One reason more to be brief. So we have seen already that energy models can be intended in many ways, and they can operate at different scales. You can model a device, you can model a plant, you can model a microgrid, a city, a country, or a group of countries. And if you take it to the extreme, you can build a global energy system model that assesses energy consumption in the whole world. Now, when you do that, one of the interesting aspects of doing that is that you can link energy to the economy, the global economy, and to climate, because climate is, of course, a global issue, and a local model can never bring you to the complete picture when you want to link energy and climate. And so when you do that, you move a bit from the realm of energy system modeling to the realm of integrated assessment modeling, where integrated assessment really refers to this combination of energy, economy, and climate. The most known institution that does that on a regular basis is the IPCC, of course, which comes up with regular reports, typically looking at very long-term projections, 2050, 2100. There are many other institutes that do this kind of modeling. We are one, ETM is also another one, and there are many more. And so we want to bring this perspective also into the Y project. Now, typically, one aspect where integrated assessment models lack is the representation of energy demand, and especially representation of energy use in buildings. So there we hope through the Y project to make a significant step forward. Next. The key objectives of this use case are to first of all, see what happens when we enhance energy efficiency. So, for example, through more efficient, the obligation to install more efficient appliances. And we want to look at what happens there in certain climate scenarios both globally and in the major economies. Of course, we want to be able to use the Y toolkit in these models, so we will also have to develop some plugins to implement the Y toolkit in our IAMs. And we will work mostly with our IAM, TMECN, and with Panagiotis IAM, which is called Prometheus. Yes, and then the whole idea is when you have this better representation of energy demand, how does that affect the results of an IAM? Next slide, please. When you work with the integrated assessment models or with energy system models in general, you need to make some scenario assumptions because you want to make projections for the long term. And so you need to have some storylines and some solid backing, let's say, of your modeling analysis. So typically, these are the ingredients that we will put in our scenarios. First of all, stringent global emission reduction targets, 2 degrees, 1.5 degrees. Then we want to really probe what happens when energy efficiency is increased versus the amount of energy efficiency that we have now. And then, given the current times we live in, we also would like to bring in the dimension of what happens when targeted recovery packages are implemented, especially in the major economies, because those, of course, influence a lot the emission landscape globally. Next slide, please. Thanks. Now, to start off, we did the first study last year, and you can see it's been published recently, where we looked exactly at that. We took some global scenarios, mainly based on climate targets, and we looked at, okay, let's now artificially increase the energy efficiency in all demand sector and see what happens. What does that lead to? And so here some of the highlights. First of all, we do see some economic benefits, especially the carbon price is significantly lower, which means that you can reach very ambitious emission reductions while keeping the costs relatively low. We also see that enhancing energy efficiency has some positive effect in the sense that certain controversial technologies like CCS, like nuclear, receive an incentive to be deployed to a lesser extent, let's say. And we see that the system costs, I should explain what those are, but let's just think about them as the cost of the whole energy system globally. Those are also reduced when energy efficiency is enhanced. Okay, I think the next slide, I had an illustration of this, but maybe in view of time, I will skip them, and then we can, if you want, bring them up for the discussion. So I'll move to the next step. Maybe you can just put all the bullets on. Yeah, one bullet too many. So next steps. Once the Y toolkit is ready, we will find a way to integrate it into Prometheus and TMECN, and we hope also to make it available to other models that are based on the same technologies, let's say, that TM uses, which is basically the times modeling framework, which is used in many energy system models. Then, of course, we will test the impact that these improvements have on our modeling results. And then we want to break down the results that we already published on a global level. We want to break them down for certain regions in the world, like the major economies, Europe, US, China, India, maybe. And see what they entail more locally. And then finally, we will bring all our contributions to the work packages 5 and 4. That concludes it from my side.
Thank you very much. So we heard from the use case managers what they set out to do and where they are right now. We have a couple of minutes to discuss. I prepared several questions, but I think because we are sitting in a session that is addressing the current energy crisis, my first question would be to all of you: how does the current situation impact your use cases and the plan you set out to do? Shall we start? with Europe.
Okay, I can start. Yeah, thanks a lot for the question. Not so obvious. I mean, the situation, of course, will radically change our plans. I mean, we plan to integrate what has already happened with energy prices. So all the analysis take into account what has happened in the last few months. And of course, not only that, but also we plan to take into account the Repower EU, let's say, measures, the short term and some of the medium term. So essentially, in the EU, this means changing some of the assumptions that we use for instance, for the different fuel mixes or for the different costs of the different technologies. And yeah, I mean, on our side, this means, especially as C3M, we are already involved. Let's say we're doing some of these scenarios already. We aim to expand a bit and elaborate more, and also trying to find ways, especially trying to link in the consumer behavior with the changing energy price. That's why I asked Cruz the previous, I mean, on what we actually expect from the changes in energy price and how this can influence human behavior. And this is actually one of the most important things to consider and make, and let's say, ground truth what we have in the models, right? I mean, with empirical estimations like the ones made by
Thanks, Panagiotis. But Thomas, you more or less explained already what impact it has on a small town. But if you want to tell more.
Just some thoughts on that. I mean, the issue is that the current situation would make the analysis of a blackout case more viable because the danger of being undersupplied in electricity is more prominent now than maybe before. But on the other hand, the problems that the stakeholder with which we have planned these actions currently has are so much more important than what we are aiming for in the project. So basically, it, in my opinion, it changes the timeline for our analysis, because we will shift all actions, all actions at the use case probably to the last quarter of this year, because until then the situation should have stabilized in the company, and the company owner and my sparring partner there should have more time to actually start thinking about the whole blackout use case again. This also aligns somewhat with the plans we have for work package 3 and the Y toolkit, so it should not change the overall result too much, just the time frame.
Thanks a lot. Well, you would think that energy communities and energy cooperatives are high in course right now. What's the impact on your side?
In Spain, I don't know, it's 3 or 4 months ago, it was a peak in the spot market, and it was on all news, obviously. And the same day, I get a message from the people we were discussing about the energy community with, we wanted to do something. So it was a trigger. I mean, I don't see as a reduction in the energy consumption. I mean, huge. I mean, we have seen already this reduction. Most probably because the high energy prices, more than the change of tariff, but probably the high energy prices. But I see the high energy prices is like a reminder that we need to change, and it's fostering, I mean, the action, taking part. I mean, it's not that you are going to change your behavior, it's that what it pushed you to do the actual thing. You have already decided that, but you need this little push. The second point that is making the huge energy prices is that it's changing critically the numbers. I mean, when you make the financial numbers, it's changing a lot. I mean, because before it was 7 years, 8 years return on investment, and now we have seen 4 years or something like that. So I mean, it's okay. This is starting to make a lot of sense to do this, and a lot of nonsense to not doing this. So This is starting to just not taking your emotional part of the brain. It's also affecting to rational part of the brain, and is moving things. So this is the bottom up, and the top down. I think that a lot of municipalities and ESCOs and other institutions are seeing that this is going to be a problem for their citizens, and so they are starting to be interested on the topic and are starting to do something. So I see this increase of prices like a catalyst or something that has made the movement to start moving the thing. Where it's going to get, I don't know, because when you start talking with the suppliers, they are starting to see, I mean, we don't have PV panels, we don't have this stupid cable that needs to connect everything, and there is a shortage of things that before was not a problem. Yeah, let's see where we get.
Yeah, and on that note, that's very apt for the global use case, because right, if we need more PV panels to create energy communities or support the supply in municipalities and renewable energies, but we don't have the material or we don't have the craftsman, where does that lead us?
Yeah, well, I think, as I mentioned, with the type of analysis we do globally, we typically look at 2050, 2100. So I think the right way to frame this question in relation to the global case is, what does the current situation, how will it affect the long term on a global scale? And so think about emissions, think about carbon prices, and so on. And I think we have two main handles that we can use in the models to try to assess that. One is the flows. So, for example, how much gas will flow from Russia to Europe, but also what other channels can Europe open. And we've seen some discussion about increasing contracts for import of natural gas from the Middle East, for example, or North Africa. Those are things we can try to test in a scenario way, in a scenario framework. And the second handle is prices, because of course all materials and energy commodities, they have certain prices, and by controlling that we can check whether, you know, a peak in price that lasts a few years might or not have an impact on the energy transition in the long term. So I think we will need to introduce a fourth ingredient in our scenario component, basically, of scenario recipe, which is indeed checking for possible increases in prices, spikes, or checking possible limitations of flows of natural gas, or a shift of imports of natural gas from other regions into Europe. But at the same time, I think it would be interesting to also check about the availability of other flows. So like think about importing electricity, more electricity into Europe from other regions, or hydrogen even from, for example, North Africa. So these are all new things that we will probably introduce in our case study in order to reflect, at least to some extent, the possible consequences of the current situation.
Thank you. Before I ask the last question and we head towards lunch, any question from the audience to the use case managers here? Or we continue? We can continue. Yeah, Chris, take a mic.
Thanks. I am still struggling to understand the implication of these global and European models on how that trickles down and how that affects how we can act on that, how we can message to our consumer members, and what we can do to understand the messages or the conclusions from these studies. Will there be a later point when we get to understand this? Or I understand it's a work in progress, right? So I'm not, or am I just not thinking it through sufficiently? That's also a possibility.
Who would like to react?
I can start, but Panagiotis, feel free to. I think it's a very good point. You know, we make these global studies, and what do they mean for Goya, for example? Well, I think maybe we should have a more dedicated discussion on that. I think there are some general messages that can be taken from the global or the higher dimensional, higher scale studies that can still be interesting for the micro scale. Like, for example, if we see that enhancing energy efficiency in households can lead to economic benefits globally or in a region, policymakers are likely to latch on that. It's also our responsibility to communicate that properly. But now, if they do latch on that, and the policies regarding the efficiency of appliances change, that will, of course, affect the consumers directly. And so it's a bit of a loop, but there is a very strong link there. Well, I'll leave it at that. Maybe Panagiotis want to add something.
Thanks, Francesco. I mean, I agree with what you said. Another aspect, which for me, let's say, is the most direct relevance to the customers of an energy company, is that through these use cases, we can provide, let's say, evidence, like scientific evidence, of why energy efficiency actions make sense, like you said. Right. I mean, we do all the economics, or the calculations, the backup calculations, etc. And of course, in an environment of very, very high energy prices, energy efficiency is the most beneficial act to do. So, or not only efficiency, but also about electrification. I mean, use more electricity than imported gas, or all these greener fuels. So I think this is, let's say, the most important, because otherwise, let's say, these high-level use cases speak more to the policymakers rather than to, let's say, consumers of an energy company. But if you can provide, let's say, proper scientific evidence, I think that people they are willing to listen to that. I think, I mean, when the new IPCC mitigation chapter came out, I think it was the most trending post in Twitter for a lot of days. So people are actually eager to listen to all that we want to say about changing energy price, about decarbonization, about energy efficiency. So we can use all these use cases, our models, our sophisticated tools, no matter if it's model or it's not, but we can provide all this evidence that people want to hear in order to be 100% sure that they want to be part of an energy community, they want to invest more heavily on buying more efficient appliances or changing the schedule of their dishwashers.
Thank you very much. Very much on the point, I think. Macarena, one more question. Hold on, there's the mic coming to you.
Today we are talking a lot about energy prices, increasing energy prices. Perhaps this question is not very much related to the Y toolkit, but I think it could be considered in the models at the European and the global models, exactly. To what extent do your models consider the increasing cost of raw materials needed for the development of renewable energies? Or they do not consider, or they cannot consider it?
I think first we change. Good, very good question, actually, Macarena. Look, I mean, usually energy system models do not explicitly take into account, but there's a very big but in that. When we, let's say, introduce what we call the overnight investment cost for PV, of course, we can make different assumptions, and then we can totally incorporate the changing prices for raw materials, right? We can definitely do that, and I think we are actually revising now the cost assumptions depending on what you said, because it's actually a very big issue now that we do not have a lot of. I think the PV prices was the first year that went up instead of the very fast decline that we've seen. So this is the first, and the second, which is quite related to that. I think also we should, let's say, have this an additional element in this use case is the reconsideration of energy security, in a sense, right? Because now, in the last 10 years or so, all the policy was more focused on efficiency, on decarbonization. We have, let's say, forgotten a bit about energy security. Now is the time to change radically, and not in a sense only about security of imported oil or natural gas. We should not forget that we also import 90% of the PV that we install, or 90% of the batteries that we want for our electric vehicles. So this calls for a more strategic thinking about all the energy transition in general, not about only fuels, but also technologies, and how this, let's say, can change in a way that we develop most of these technologies domestically in the EU, creating additional value chain, creating more jobs, etc. But because it does not make a lot of sense to substitute imported natural gas with imported PV or imported hydrogen. Okay, so this cares for reconsideration, though some of these aspects are at least taken care in the models and in the KPIs we produce. And I leave it to Francesco for the rest.
Yeah, thanks, Pangiotis. I have very little to add. I mean, he said it all. I think maybe the only other thing that I can add to that is that one important parameter that we always tweak in our models is that all the different regions in which we split the world, they have a certain potential for deploying technologies. So, of course, you can put PV panels everywhere and solve the energy crisis. That is, but in the potential that we put in the model, which is a limitation basically on how much PV or wind you can install, among other things, we take into account also the availability of materials to produce those technologies. And so it's prices, but it's also how much of a certain technology can be deployed. And that's always done in a scenario approach. So you can create a scenario where you limit artificially this maximum amount of PV, for example, that you can deploy, because you expect a shortage of raw materials.
Thank you.
And just one thing to add, and that's a teaser for post-lunch sleepiness when I present work package 3. In the white toolkit, we are also considering or able to consider raising investment costs for technologies when it comes to household investments. So investment decisions might be different when single individual technologies have higher prices. And this will then, of course, affect the large-scale models because the bottom layer of energy supply, the decentralized energy supply, will have a different structure than it might have had before. So we addressed that, I think, on all levels that it's possible to address. And let's see how that will affect the results later on.
Thank you very much. And not to forget that if we talk about energy efficiency, the renovation of buildings is, and the lack of craftsmen and high prices for renovation, isolation is also a component here. But we're not going to go there because it's lunchtime and we're past time now. So thank you very much for tuning in. Thank you for your thoughts and your presentation, and enjoy your lunch.